One of the major new features that TrueNAS Scale introduced over Core was the inclusion of easy-to-deploy applications through the TrueNAS Apps catalog. These apps can be run directly on your TrueNAS Scale machine with much less overhead than traditional virtual machines, while still having close access to your storage. To get started, navigate to the Apps page in the sidebar. You'll be asked to select a pool for your apps. This is where the applications themselves will be downloaded. It doesn't have to be the same place that the apps will read or write their data to. Think of it as the program files folder for where the applications themselves will run. For the best performance, this could be a pool made of solid-state devices, but because the apps also benefit from ZFS's read and write acceleration, a hard drive-based pool can work just as well for lighter workloads. Once your initial configuration is complete, you can check out the listing of available apps in the catalog. Some are designated as official TrueNAS apps, such as Nextcloud, Storj, or Pi-hole, while others are considered community-supported, such as the popular open-source media server Jellyfin. We'll install that as an example, but before we continue, we'll make a quick detour to change an advanced setting in the Apps page specific for this application. Under Advanced Settings, we'll need to uncheck the Enable Host Path Safety Checks option in order to allow simultaneous sharing of folders between both NAS protocols such as SMB and the apps themselves. Because this setting does allow for both the app and another source to access the same files, issues can arise if both the app and a connected client over a NAS protocol try to modify a file at the same time. Since the Jellyfin app is only reading from the shared files, the risk of corruption is smaller, but for applications such as Nextcloud, Collabora, or SyncThing that could potentially write to files at the same time as a remote client, it's a good idea to set up ZFS's snapshots to protect your dataset from accidental damage. Once the setting is saved and updated, we'll want to create a folder to use with the Jellyfin app. Return to the Datasets page, and we'll create a new dataset called Media. At the bottom of this section, we'll select a share type of Apps, which will automatically give the TrueNAS Scale Apps user access to this folder. Once the dataset is created, you can see under the Permissions section that the Apps user, with user ID 568, has been allowed a special type of access. We'll now share the media dataset over SMB, so that we'll be able to copy media to and from this folder from network-connected clients. Returning to the Apps window, let's use the Available Applications page, and we'll search for Jellyfin by name. For official and community applications installed from these app catalogs, many of your default chart options have been pre-populated with some available tooltips for more information. Notice that under the User and Group configuration, we can see the user ID 568, which is assigned to the apps user that we gave permission to the dataset beforehand. Like most official apps, this Jellyfin chart uses a pre-configured network port value. This may be different from the software default, so take note of this for future use when you're connecting a client to this system. The next step is to assign storage to the app. Each app can have a different number of volumes, so it's important to understand how many are required and what the app will do with each of them. Most apps will at the minimum have a configuration volume, where the application itself will store its settings. By default, TrueNAS Scale apps use the IX volume type, which is an app-specific dataset in the same pool that you selected during initial app configuration. Jellyfin also uses a separate volume for caching media metadata, such as thumbnails, ratings, and reviews. This is different from ZFS metadata, so it needs to be stored in a format that Jellyfin understands. Finally, the transcoding volume holds temporary copies of files that are created when changing the format or bitrate of a file on the fly. Because these files are temporary and we don't need them to remain around when the container is stopped or upgraded, we can use the empty directory storage type. Once selected, you can choose to use either the disk or memory storage type. For many cases, disk storage type is safer, as the memory type may consume some of your available system memory that could otherwise be used by TrueNAS for the ZFS read or write acceleration, or for the app itself to work with. Because each app does have different requirements, it's important to consult the documentation provided by the app developer themselves if you'd like to determine how to best set up the storage volumes. In this case, we'll use the disk type medium and we'll set a size of 32 gigabytes to allow for multiple simultaneous transcodes to occur. Once we've configured the storage for the app itself, we need to attach our media folder. Choose to add an additional storage type and change it from IX volume to a host path, which lets us present a dataset directly from our ZFS pool. Select the media dataset under the evaluation pool as the host path, and then enter a mount path that will be shown inside the application itself, in this case, /media. For some applications, a GPU resource can be added in order to accelerate specific workloads, such as media transcoding or machine learning. Most recent Intel and NVIDIA GPUs can be used for this purpose, but it's important to check the software release notes and compatibility before purchasing hardware. Click Save, and TrueNAS Scale will validate your configuration. Then return to the Installed Applications page to monitor the download and deployment of your app. Once the app becomes active, you can see the port number assigned, as well as click on the Web Portal button to launch the app itself. While configuring the application, note that setting up the media library requires the use of the mount path folder of /media, rather than the host path of mount evaluation media. We'll complete our setup here and sign in. Then, just to demonstrate, we'll copy a movie over to the shared media folder from a Windows client. While Jellyfin can automatically refresh its libraries, we'll hurry this process up with a manual scan of the shared folder, and upon returning to the interface, notice that our movie has been indexed, with a thumbnail, rating, and summary available, saved to our cache volume that we configured when we installed the app. iX Systems has worked to bring many of the most common and popular apps to TrueNAS Scale, but if you're not able to find your desired app through the catalog, you're an experienced Docker user, or you're developing your own application, there's also the option to launch Docker images manually using the Launch Docker Image button. This process exposes much more of the Docker configuration steps, container entry points, environment variables, and custom network settings. Each Docker container will require different settings. In this case, our demonstration Nginx web server only needs a port forwarding rule to make its internal HTTP port 80 visible on your TrueNAS server's port at 9080. Note that when entering a custom port, TrueNAS Scale does require that you choose a port that's over 9000. Ports below this value are reserved. Complete your configuration, save the chart, and then monitor its deployment from installed applications. Navigate to the IP and port shown to access your Docker image. If you decide you no longer need an application, you can stop it from within the TrueNAS Apps page, and then use the additional menu settings to delete the application. You can also choose to delete the Docker image itself that was downloaded onto your TrueNAS Scale machine to free up some space. Note that if you delete an application with data saved in an IX volume, that data will be removed, but data stored in any shared host path volumes will be retained after deletion.